Logarithmic functions. Logarithmic functions are the inverse of exponential functions. So for example, if we have an exponential function that looks like this, the equivalent log function would look like this here. And so what was the y-intercept on the exponential function becomes the x-intercept on the log function. So the domain of a log function is the reverse of the domain on the exponential function. So the domain of a log function is x is greater than 0. And the range of a log function, so the range on a log function is y is all reals. So that is the opposite of what we had with the exponential function. Now log functions undo exponential functions. So let's look at how that happens. Now as we see, log functions and exponential functions are inverses of each other. Specifically, the exponential function has the equation y equals b to the x. And the log function has the equation y equals log base b of x. So y equals b to the x and y equals log base b of x are inverse functions of each other. Notice the y-intercept on the exponential becomes the x-intercept of the log function. But what is the y-intercept of the exponential function? Well, the y-intercept of the exponential function occurs here at 1, remember? So therefore, the x-intercept of the log function is also at 1. What does that mean? That brings us to one of the properties of logs, that the log of 1, no matter what b is 0. The log of 1 is 0. So that's a very important property to note of logs. Now our base here, the bases we've been talking about, if you recall from the from the exponential functions, the base is between 0 and 1 or greater than 1. So generally, the base is going to be between 0 and 1, or the base is going to be greater than 1. So the base is not negative, and the base is not 1 either. Okay, so that's the base of the log function. Now, so these are inverse functions. Remember, inverse means that they reflect across this line here, y equals x. And it also means the domain and ranges are flipped, and it also means that they undo each other. So let's look at that property. So we said the log and the exponential function are inverses. So what does that mean? Well, if I have the log base b of b to the x, that just gives me x, because they undo each other. Conversely, if I have b raised to the log base b of x, that also gives me x. So they undo each other. There's some other properties. As we've seen, the log, and it doesn't matter what base you're talking about, the log of 1 is always going to be 0. And also, this another property is the log base b of b. Well, remember in this case there's no x, so we can assume x is 1. So the log base b of b is just going to be 1. So those are some properties of logs that are good to know. Now, there's specific types of logs that are used a lot in math, and one log we have is called a common log, where the base is equal to 10. And another log that we use a lot of in math is called a natural log, where the base is equal to what we call e, Euler's constant. We've seen that in exponential functions. So if we have a base e on the log, we call it natural log. If the base is 10, we call it the common log. And we're going to take some examples of usages of these logs. So some examples of logs, uses of logs, is the Richter scale. The Richter scale says R, the Richter level of an earthquake, is equal to log of I, which is the intensity of the earthquake, divided by I naught, which is the intensity of the lowest, the smallest earthquake. So that's a Richter scale is a logarithmic scale. Also, a pH scale is a log scale. And the log scale, the pH is equal to the negative log of what we call H+, the hydrogen ion concentration. So that is also a log scale. And what log are we talking about? Where's the base? These are all base 10. So these are all base 10 scales, something to take a note about, these types of scales. Now the natural log is used a lot in solving equations involving population growth, and we'll see that as well.